Hi folks, this is number 14 on page 444. They give us these two lines and they tell us that the angle between them is 60 degrees and they want us to find that missing k value. Okay, so if you just think about this geometrically, so let's say this is one of the lines. Okay, so say this is one. You have this line here which say has an angle of 60 degrees. Okay, but you can also draw this line here, which also has an angle of 60 degrees. Okay, so essentially the reason why I'm just thinking about this is I wouldn't be surprised if this ends up giving me two solutions. Okay, so let's go ahead and solve this problem. So we know that the angle between two lines is going to be the same as the angle between either the direction vectors or their normal vectors. And since these are given in Cartesian form, I'm going to work with the normal vectors. So the normal for equation 1 is equal to 1, negative 1, and the normal for equation 2 is 1k. Okay, and in order to find the angle between these two vectors, we're just going to use a dot product. Okay, so we have 1, negative 1 dot 1k is equal to the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. Okay, which in this case here is 60 degrees. Okay, and here we see the only thing left is k. So let's solve this here, find the dot product. So we have 1 minus k, and then here we have a square root of 1 squared plus 1 squared, so that's just going to be the square root of 2. Here we have the square root of 1 squared plus k squared. Okay, and here cosine of 60 is just equal to 1/2. Okay, now we have these square roots on one side of the equation, so we'll definitely want to square both sides in order to solve this, but I'll start by first bringing the 2 to the other side just to get that out of the way. So this will become 2 minus 2k, and this here, if we multiply it out, since we can do that when we're multiplying radicals, just gives us 2 plus 2k squared. Okay, and now I'll square both sides. So square this side here, we end up with 4 minus 8k plus 4k squared, and on the other side, well, we're just going to get rid of the square root, so 2 plus 2k squared. Okay, and lo and behold, what do we have? A quadratic equation. So looks like we had the right idea that there might be two answers here. Okay, so bring everything to the right, so 2k squared minus 8k, and here 4 minus 2 is 2, equals 0. I'll simplify that by dividing both sides by 2, so k squared minus 4k plus 1 equals 0, and that's clearly not going to be factorable. So just use the quadratic formula. So k is equal to negative 4, so 4 plus or minus our negative 4 squared, which is 16 minus 4 times 1 times 1, all over 2 times 1. Okay, so here we have 4 plus or minus, and this is 16 minus 4 is 12. Okay, and if we simplify this here, okay, this is 4 times 3, so we have 2 root 3. And lastly, we can finally just divide 2 to both of these, so 2 plus or minus root 3. Okay, and there's our final answers. So just to recap here, a reminder that to find the angle between two lines, you can either find the angle between their direction vectors or normal vectors. Since we have Cartesian form, we use the normal vectors, and in order to find the angle between two vectors, we can use the dot product, and it's from here that we were able to solve for k. Okay, so there's the full solution, and that's it for this one.